multiprocessing. It is a concept in Python where we can run our application as multiple processes in the same machine, same Ubuntu or Linux machine, right? But usually this is not the same concept in other programming language like from Java or C++. We don't need this multiple processing, or because each and every process in Java or C++, by default it runs on multiple cores. Whereas in Python, it is only possible we can use maximum of one core even though the computer is multi-core system. that makes the need of multiprocessing in Python. So in this tutorial we will go through why this limitation is appearing in Python, and some behind scenes, like why even though it is allowing creation of multiple threads in Python, still is it worth to create multiple threads in Python since it is using only one core? What is the impact and what is the resolution? All that the basic concepts behind the multiple processing we will see in this tutorial. Okay, for example, let's start with the for example, if in Java, like if you are creating a threads, right, multiple threads, it will be usually run executing on a different cores. The thread allocation, all it's based on the OS level which thread it has to run. But usually if you are creating a multiple threads in a programming language, it is if the thread is corresponding OS thread. Okay, OS thread means it can be in the OS level. Each thread, in the programming code we are creating one thread that will be corresponding OS thread, OS level thread. If that is same OS level thread, then operating system will decide which thread to run and which thread it can preempt. Okay, so this is a usual case. Okay, so this is a usual case. Whereas in C Python, okay, C Python also the thread is equivalent. One thread is equivalent to the OS level thread. Okay, OS level thread. That's why creating a thread is costlier. So we have to use pool in the sense of we can reuse existing threads, so that the creation of threads in the OS level is costly. So we have to use a pooling of threads. Okay, so in Python it allows us to create multiple threads, right? Then it has to also run in multiple cores, right? That is expectation. But the problem in C Python is a global interpreter lock. This is the design in Python which makes sure that only one thread at a time can use interpreter to run execute a code. This was deliberately done in Python, assuming that to make the interpreter very simple and make sure thread safety on the memory management. Memory management means the accessing object or modifying an existing object without any race condition, without any data corruption. So to make sure our Python interpreter too simple, and this design choice was made, and it was make sure that it is only one thread can execute at any point in time in Python. Okay, so this is the reason, even though you are creating multiple threads in Python at any so it will be only one thread can run. Okay, so this is same like these kind of concepts, like even Node.js has this kind of concept. Only drawback is if we cannot use something like CPU intensive jobs, right? If you are computing, if you are doing for loop, or you are computing some objects, then these programming language will not perform as like multi-core languages, operating multi-core languages, right? So this is a limitation. To overcome this limitation, so the overkill. Okay, let's go by slide. So this is one example what happened at GIL. So for example, if thread is running, the other two threads will be waiting for the lock. The log is global interpreter lock. So to get that lock, it will be waiting until the lock is released for another thread. Then only it will start. Okay, so so why then this answers why still threads are available in Python. Because when it is not CPU intensive job, if it is IO related jobs, like you are waiting on a socket, or you are making an API call to another service, or if you are making any database operation or any disk operation, IO operation, this all IO operation which will not really use your CPU. It will not really use your CPU. So if you are making any such choices like IO operations, you still can use your threads in Python. Okay, without any, even though the global interpreter log is there, it understands that this thread needs IO, it's waiting on IO, so it will allow other thread to execute, so it won't block more the waiting time of IO. So it will, so you can execute parallel threads for IO operation. Okay, the other choices we can use some C extension based libraries like NumPy, Panda, SciPy. These libraries internally implemented in C. So this we can use it. This don't have that global interpreter log concepts. So if these libraries we are using, then we are good. Okay, so if you are doing a IO related operation, even since, as I already told, the thread is equivalent to operating system thread, so we should, instead of creating threads every time, we should use pool and reuse the pool for multiple time execution, so that it won't we are not creating operating system resources in our code base, right? Okay, so this we understood. Now, okay, now let's go to multiprocessing, how it is solving that problem. Okay, the multiprocessing pool. So this initially the pool I was mentioning was a thread pool. I mean, there is a thread pool concept also in Python. So if I'm explaining about multiprocessing, this multiprocessing pool is little different. Okay, so what it will do is it will create its own process to execute some of the work. Okay, so it means that my application is running, the replica of my application is running like 8 times, and my code is shipped to that application and executed, and the results are written back. It's like you are running Python, then Python file multiple times. So it's running of your application multiple times. Okay, usually this is not the case. We may run the same application multiple times for scalability on a different machine, for availability and scalability, but this concept is like within the same machine itself we are running a multiple process. Okay, this is just to overcome our Python limitation of GIL. Okay, how this works, because every process owns its own interpreter and its own global interpreter log, and it uses its own individual core. Okay, so yeah, that's how we are recovering from this problem using multiprocessing. Okay, so let's go a little bit deeper on what is process versus thread, because that underlying concept is important. We should not understand that if I have two processes, I can run only 2 times, right? If you have multiple threads running, okay, because the OS will execute only thread, it doesn't care about process. The process is just a container for memory space or interpreter, where the interpreter code is there, OS level resources. Okay, these are all only the process is not really executing. The thread is what it will execute the code in real CPU, inside the real operating system CPU. Okay, so if you have a 2 process but 100 threads, then you are using 100, then it is possible that each thread can run parallelly on multi-core system, right? So yeah, even though number of process is less, I hope you understand this process and thread differences, right? But all thread, why we need within the same memory space we can use, so if memory space within the process, within that threads, it is shared. Okay, but if you want to do one process sharing some data to another process, then we need some message passing or mesh or memory space sharing, those concepts are needed. If you are the interprocess, the multiprocessing here, it is something that kind of, it is not individual process, maybe it is spawning, and we have to share our data to that process, then it will execute. Okay, yeah, so we will talk about it much more later. Okay, okay. Okay, let's go with the OS CPU scheduler. So the operating system level CPU scheduler, which decides which thread to run, which CPU core to be allocated, and how long it can run, when to preempt, I mean pause the thread, when to, because we have to switch over that to another thread. This all happening at the OS level. Okay, and the process are not really running actually, but you can kill the process, and then in terms it will kill all the thread within that process, but actually the CPU is running the threads. Okay, okay. Okay, so this is how it will, like, one process A can run one thread, and even it can run another thread parallelly in different core, the same process. This is possible. Okay, for yeah, if this OS thread is from the programming language that supports multi-thread processing, multi-thread core processing. Okay, this is possible. Okay, okay. Let's go back further. Okay, since we are using, since this global interpreter lock is there, and I created a two process CPU intensive process. Okay, since global interpreter lock is ensuring that only one thread is running, is it have any impact on your machine? Yes, it has an impact. It will waste your CPU time. Okay, uh, because the OS does not know that there are uh, threads created within Python, but that thread is not actually running. So OS level thread scheduler doesn't know that you created a log and your programming language is restricting that because of you have a lock. Okay, so what will happen? So if assume that you have scheduled, so usually OS schedules thread 1 on core 1. Okay, and it is scheduling the next thread within the same process. Okay, on core 2, but actually this thread 2 is trying to occupy the lock, and it is blocked, and the whatever time CPU time allocated for this thread is wasted, right? So even though you have CPU intensive job in Python and you created multiple threads, actually it is not running, but still you can see your machine, that process is taking much CPU, but it is actually not running what it is used to be running, right? So 3 cores are basically busy doing nothing useful, right? So make sure if you are creating multiple threads within a Python without multiprocessing, right? Then we are not actually using the complete OS resources. Okay, okay. So what else the bottleneck with global interpreter lock? The other global interpreter lock drawbacks are, it has to make sure that which thread is same like OS scheduler. This global interpreter lock also has to prioritize which thread to run, when to preempt, how to create a context switching, all that, right? So this global interpreter lock itself will create some performance drop in the system, right? So yeah, this is additional thing when you have multiple threads you are using it. Okay, okay. So it makes that if you have 4 thread, it doesn't make it doesn't like it is using 4 core. Actually, the performance output, even though you created 4 core, you will be only using 0.7% of single core is the performance you will get output as output. Okay, okay. So let's go further. Okay, since so we can ask why OS scheduler, since the thread is blocked on global interpreter locks, right? Why it is not preempting? OS scheduler is not preempting that thread, and then it can allocate to other thread. The problem is OS level does not know what's going on. Okay, so it knows only that the lock is within the application level. Okay, it means it's GIL is only internal user level, so OS scheduler does not know, and it cannot it doesn't know, it assumes that the threads are running, but it is not actually running. It is trying to acquire the lock. Actually, in it's called a spin wait for global interpreter lock. It's keep on polling for getting the lock, and nothing it actually doing. Okay. Finally, we have the Python 3.13 version. They were tried to remove this global interpreter lock so that we can maximize the CPU intensive work in Python. Okay, so this is coming. No GIL free threading concept is going to come on C Python. So it usually removes this global interpreter lock, and it is going to create a lock on object level, and this needs a change over your memory management also, like garbage collection, or how each object is locked so that it is not corrupted, or no race condition. So instead of one global lock, they are going to introduce a lock at object level so that we can run multiple threads parallelly. Okay, yeah. So this is so in 3.13 free threading concept, threads can run in parallel on multiple core, no more GIL contention, and multi-threading becomes faster and efficient. Okay, so yeah, that is possible. Okay, yeah. So then, can I use this 3.13 now? The answer is still no, because your libraries has to adopt for that. Okay, your libraries means pandas or all whatever libraries you are using, that is under understanding that Python is using GIL, right? So they also have to adapt. Then of course you can use it, and so you and even this you have to check which version of Python is removed. Even in the same 3.13, there is two types of software version they are going to ship. Okay, one is with the GIL and without GIL. Usually the Python ends with a T, the 3.13T. It means that it is free threaded, there is no thread. Then you can choose that way, and you can continue using the multiprocessing. Okay, so in the next video I have explained about how to create a multiprocessing per process level, or how to use that in a pool level. I have a code example in the next version. Then I have debugged via code debugging from Visual Studio Code, so that you can understand how this process is creating. Maybe in the next video, initial few of the time I have explained about the basic of Python, because some of the code you may have a doubt, so I explained. If you are good at Python, you can skip that and you can directly go to the code execution of how to create a Python multiprocessors. And next video I can share how I can explain about how the storage shared between multiple processes. I can cover that in next video. Hope this is useful. Thank you for watching. Bye.